Okay, I'm going to go through these examples. In the 2000s, health awareness began to gain momentum. In 2002, the Consumers Union conducted an investigation for the presence of bacteria in packages of chicken sold in supermarkets. They purchased Perdue chicken and store-brand chicken in 25 U.S. cities. The lab tests found bacteria in 33% of the 91 Perdue packages and 48% of the 85 store-brand packages. Does this indicate that the shopper should be safer buying Perdue chicken? Safer probably meaning less bacteria. So, does this indicate that the shoppers will be safer? State whether you reject or fail to reject HO and state your conclusion in context. So this is clearly a hypothesis test if we're going to be having this null hypothesis. So first I'm going to make my hypotheses and label what I have. So I have these two groups. I have the Perdue chicken and I have store brand. And so I have a 91 store brand chickens and 91 Perdue chickens and 85 store brand chickens. 33% of the Perdue chickens had bacteria and 48% of the store brand chickens had bacteria. And now I'm going to think about my hypotheses. I want to show that Perdue, safer buying Perdue. So Perdue is safer than store brand, meaning Perdue has less bacteria than store brand. So I want to show the P of Perdue, the proportion of Perdue chicken that has bacteria is less than the proportion of the store brand. And so my null will be that's the same. Okay, and so now I'm going to go ahead and check my conditions to make sure I can make a normal curve. So I need to make sure my samples are big enough. I can do my Q hat if I want to, which is 1 minus 0.33, 1 minus 0.48. And so I make sure it's big enough, 91 times 0.33 and 91 times 0.67. This is 30, so this is 61, and they're both bigger than 10. And I do the same thing here. This is 41, so this is 44, and they're both bigger than 10. So it's big enough for a normal curve. So that's true. We need to make sure that these samples are independent. Well, the Perdue chicken is independent of store brand chicken. And we need to make sure that our sample is small enough compared to the population. So 91 is less than 10% of all Perdue chicken. And that's true. And that's probably the same for the store brand chicken. So it's small enough for independence, and we have to assume they were randomly selected samples. So with that in mind, we can make our normal curve, and our curve is going to be comparing Perdue and store brand. So we're going to be looking at Perdue chicken compared to store brand chicken. And remember, when we compare things, we really look at their differences. So we're taking the difference. And so in our HO, we assume that the percents are the same, and therefore the difference is 0. So we're assuming that they're the same, but samples will vary, and so we need to calculate that variation. by pooling our P's together and then finding that standard error. So we find our P pool, and that's the successes. So 33% of 91 is 30, and 48% of 85 is 41 over our sample sizes. .403. And then we calculate that standard error for that pooled value. And we take our P times our Q over the first N plus our new P times Q over the second N. And that gives us our standard error. .074. So that means that we're going up and down by .074 every time, etc. All right, and so now what we need to figure out is where do our samples stand on this curve? So I'm looking at Purdue minus store brand, so I want to figure out where is my difference. So when I take Purdue minus store brand, I get negative 0.15. So I'm somewhere over here at negative 0.15. So I need to figure out how far away from the center am I? How many standard errors away from the mean am I? Well, that's a z-score. So I figure out, okay, I'm at negative 0.15 minus the center, 0, over the standard error. And I figure out how many standard errors away from the center I am. And I get negative 2.027. And then I want to figure out what's the probability I could get my sample or less, assuming that they're the same. So assuming I'm on this curve, what's the probability I could be this far away from the center or below? I went to second VARS, normal CDF, and this is our probability. So with a significance level of 5%, comparing this to 5%, I can see, well, since it's nearly impossible for me to get my sample, given that there's no difference in Purdue and store brand, it must mean that this hypothesis is true. Purdue is less than store brand. So since p-value is less than 5%, I reject HO and have evidence to show Purdue with bacteria is less than store brand. So rejecting HO. Okay, and now I'm going to do number 2, the confidence interval, which is the new stuff. Construct a 90% confidence interval for the difference in bacteria found in Purdue versus the store brand. So now I want to figure out, okay, so my difference is 15%. What's true about the population of all Purdue chicken compared to all store brand chicken? What's that range of difference in bacteria? So I take my sample and look at my sample, but my sample could be off by some margin of error. So I'm going to follow this here, and I have my difference there. And with a 90% confidence interval, I am going to use a z-score of 1.645. So I use a z-score of 1.645, and then I need to calculate the standard error here. We are not using the pooled standard error because we don't have a hypothesis to pool them together, so we're just going to use the p-hats we have. We might find that we actually have a little bit larger of a standard error. A little bit smaller of a standard error. So my margin of error is 0.1205. I'm going to go with 0.12. And then this was negative 0.15. So if I subtract, I get negative 0.27. And if I add, I get negative 0.03. So what I'm saying is I am 90% confident that the percent of Purdue chicken with bacteria is between 27% and 3% less than store brand. I say less because these both have negatives. So I'm saying that Purdue is less than store brand. And that's exactly what happened in my hypotheses here. I rejected HO, that they're the same, and I accepted that Purdue is less than store brand. Okay, so 0 is not in the interval. So Purdue bacteria is not the same as store brand. If 0 was in the interval, we would be saying it's possible that they're the same. But in this case, there's no 0 in here. It's impossible that they're the same. In fact, what we're showing is that Purdue is lower than the store brand. Okay, we're on the left side of that number line. Right, this being Purdue is the same. The percent with bacteria is the same. And what we have is two negative numbers showing that Purdue is lower. Okay, it's not possible. 0 is not inside the interval. All right, and that's the chapter 22 practice. Just a run through of that for you if you want it. We'll do the back side, number 3 and number 4, or page 2. So in 2000, the United Nations claimed that there was a higher rate of literacy in men than in women from the country of Qatar. A humanitarian organization went to Qatar to conduct a random sample. The results revealed that 45 out of the 234 men and 42 out of the 251 women were classified as illiterate on the same measurement test. Do these results indicate that the UN findings were correct? So the UN is claiming that there's a higher rate of illiteracy in men. And we don't want to deny the claim, we want to prove the claim is correct. So we want to show that there's a higher rate of illiteracy in men than women. So our two groups are men and women. And we want to show that men are higher than women. In illiteracy. So the results revealed that 45 of 234 men and 42 of 251 women were classified as illiterate. So All right, so now I've labeled everything and I have my hypotheses. I need to check conditions. These conditions are all gonna pass. I don't want this video to be too long for you, so it passes conditions, which means we can create our normal curve. I'm looking at men compared to women, so I'm gonna look at men compared to women. And I'm gonna assume, I have to assume HO is true until I can prove it wrong. So I look at my HO and I see men minus women. If they're the same, their difference should be nothing. If they're the same, they have no difference. But samples do vary, so I'm looking at my sample, and I know that not all samples will be the same, so I need to figure out how much do the samples vary by. So I'm gonna pool these together. And find I have a p-pool of 0.179. And then I'll create my SE pool, my standard error, to find that variation. .035. And so this is my standard error, and now I want to see where does my sample lie. So I'm going to look at my samples here and look at my difference. And I see the difference for my samples to be .192 minus 0.167 is 0.025. Okay, and my standard error is 0.035. So I am somewhere right in here. And I want to look at greater than. Looking at my curve right away, I know my p-value is actually going to be pretty big. It's going to be close to 50%. But I will actually calculate that p-value. I need to find out what percent of this curve is shaded. What's the probability I could get my sample given HO is true? Is it possible to get my sample? So I calculate my z-score. How far away from the mean am I? So I'm at 0.025 minus the center divided by the standard error. I am 0.714, standard errors away from the mean, and now I need to find that probability of going higher than that. My p-value is 0.238, so since my p-value is high, if your p-value is low, you reject HO, but my p-value is high. It's above 1%, it's 23%. I fail to reject HO. It's possible for me to get this sample difference if men and women have the same illiteracy rate. So I fail to reject HO and don't have evidence to show males have a higher illiteracy rate in Qatar. Okay, and then I would do the same down here that I did on the other problem. Construct a 98% confidence interval for the difference in gender literacy. So I want to know, okay, what are the possible ranges in literacy differences? So my difference is this, but it could be off by some margin of error. 98% goes with a z-score of 2.325. And then that standard error combines these guys. PQ over N square rooted is that standard deviation formula. Okay, I'm just going to calculate the margin of error together. And I get a margin of error of 0.081. Okay, and then I can do the subtraction side and the addition side. Subtraction's a little harder. Notice that 0 is in the interval, so it is possible that there is no difference in illiteracy rate, which is what we were saying up here, is that I don't have enough evidence to show there's a difference. So it's possible that there's no difference in illiteracy rate. So this 2% difference is not a significant enough difference. Maybe if we had a higher sample size, but with the sample size we have, that's not a big enough difference. Okay, if we had a larger sample size, our standard error would be much smaller, which would make our z-score bigger, and so we would get further away from the mean and therefore have a smaller p-value. But with the sample sizes we have, there is not enough evidence to show that there's a difference. It's possible that there is no difference in illiteracy rate. Okay, if I were to interpret this interval, I would say I am 98% confident that the percent of illiterate men in Qatar is 5.6% lower to 10.6% higher than illiterate women. Okay, and that is it for the Chapter 22 practice worksheet.